Thank you for that introduction. But before we get started, let me tell you a little bit about myself. I've been working with SQL Server as a developer, administrator, and architect for a long time. And about 2.5 years ago, I joined the wonderful team at AWS. I've since learned why I believe AWS is the best platform for SQL Server. And one of the things I like to do is share that knowledge in forums such as this. So why are we here? Well, if you don't already know, Microsoft is ending extended support for SQL Server 2008 and R2 on July 9th of next year, 2019. And they'll be doing the same for Windows Server 2008 and R2 on January 14th of 2020. Both dates are important to remember, but we're going to focus on the earlier SQL Server date during this webinar. So what does this mean? Well, you're probably already aware that mainstream support ended back in 2014. So there have been no product enhancements since that time. Once extended support ends, Microsoft won't even be supplying security or reliability fixes without a separate paid support agreement. Now at this point, I hope you don't look like this, and I hope your boss doesn't come to you looking like this either. The good news is we're here to help. You don't need to worry because we love Windows. In fact, more and more people are moving to public cloud, and IDC estimates that almost 60% of public cloud Windows instances are running on AWS. So why is that? Well, here are just some of the reasons why our customers are choosing to run their workloads on AWS. I won't speak to all of them now, but I want to highlight a few points that might not be obvious on this slide. I listed security first because it is always our #1 priority. In fact, our CEO, Andy Jassy, refers to security as job zero. I put experience and innovation together because our experience of over 12 years in public cloud, along with millions of active customers, combine to form the biggest driver behind the thousands of innovations that we produce as new or enhanced services and features each year. We'll talk more about innovation in a minute. But first, I want to show you our latest world map. As you can see, we have regions across the globe, and the green circles show future locations. But the important thing I want you to remember is that each of our geographic regions has at least 2 availability zones. So what is an availability zone, or AZ as we call them? Well, each AZ consists of 1 or more data centers clustered close together. Each availability zone is isolated on a separate power grid in a separate floodplain, miles apart, but we maintain very high bandwidth and low latency between zones within a region to allow you to do things like synchronous commit and automatic failover, like we'll see later in this presentation. So I mentioned innovation earlier, told you we'd come back to it, and here it is. This is a nice snapshot just showing the innovation specifically related to Windows and SQL Server. And you can see there are a lot, and the pace is quickening. All of this has led to substantial growth of over 400% in the number of customers running Windows on Amazon EC2. You've heard me explain why I think customers are doing this, but let's see what some of them are saying for themselves. I'm not going to read the quotes, but you see the familiar themes of ease of use, innovation, and cost savings. So now that we know why AWS is the best place to run Windows and SQL Server, let's talk about getting there. Once you've decided to run SQL Server on AWS, you have 2 options. The Amazon RDS managed service, or a self-managed instance on Amazon EC2. Let's take a look at Amazon RDS first. So what do we mean by managed? Well, we're talking about this whole stack here. Patches, backups, even high availability. In fact, HA is my favorite feature of RDS because it's HA plus with automatic host replacement. So what does this do for you? Well, imagine if you configured 2 servers for HA. You even tested to ensure it worked. Then one day, your primary server crashes and a failover happens. Great job. Your HA configuration worked perfectly. You're proud of yourself. Of course, wait a second. Now, unfortunately, you only have 1 server. If you're on premises, this might mean contacting procurement, having to bring in a new physical machine. This could take a long time. In the cloud, of course, it's faster. You spin up a new instance, and then you can reestablish HA from there. But with RDS, we do all of this for you. If your primary instance failed and needed replacement, all of it happened, that would all happen automatically, and HA would be reestablished without you doing a thing. Now, if you're a DBA, this just means you have more time to figure out whose query is spiking the server and why. So what about Amazon EC2? We're still going to be managing the hardware and the infrastructure, but you'll have administrative rights to take care of the rest yourself. I'm going to talk about Amazon EC2 later, but first let's take a deeper look at RDS. Here you can see the range of vCPU and memory options available for SQL Server on Amazon RDS. Once your instance starts, CloudWatch will provide monitoring information. If you want to dive deeper, you can enable enhanced monitoring or use a third-party tool. So let's take a look at the Amazon RDS architecture. And you can see here the familiar faces that you'll see across AWS, VPC, 2 availability zones within 1 region, private subnets, and there we have the RDS instance. Now, the first thing you might notice is I'm talking about an RDS instance, but this diagram is showing 2. Well, that's because in this case, I'm showing that multi-AZ high availability feature of RDS. So this is considered 1 instance, but with that automatic failover. If you want to look at this a little bit deeper in terms of, well, exactly how does that work? That's the real beauty of RDS. It's a managed service. You don't need to worry about the details because we're here to do that for you. All right, so what about Amazon EC2? Well, as I've said, there's more flexibility there, also more responsibility. So let's get into some of the decisions that are involved in an EC2 process. First question we're going to want to look at is licensing. For Amazon EC2 and running SQL Server, your first question is, do you want a license included instance from AWS, or do you want to bring your own license? If you choose the latter, then your next question is, do you have software assurance with license mobility? If you do, you can use default tenancy, and if you do not, there are dedicated options available. It really is that simple. We do have a wide range of options available on Amazon EC2, but most of the time for SQL Server, you're going to want to look at this middle option of memory optimized. So I chose one of those, our R5D instance family, and you can see here the range of options similar to what you saw with RDS, you have a range of options in terms of vCPU and memory. And in this particular case, this also includes instance storage, and that scales as well. But what if you want even more flexibility? What if you want an even greater ratio of RAM to CPU? Well, that's where we have a feature called Optimized CPUs. This is great for those BYOL situations where you really want to save money. You don't want to have, SQL Server, of course, is licensed by the core. You don't want to spend a lot on that SQL Server license. That we all know that can get pricey, especially if you're looking at Enterprise Edition. But what we can do here is you can get one of those higher end instance types that we saw, and then use the optimized CPU option to say, okay, but only make accessible, like you see here in this particular case, in the second option, we're saying choose an instance type with 32 vCPU, but I'm only going to have 8 of those active. I still get the full RAM capability and the instance store capability and everything else of that R5 8x large instance type, but I'm only using 8 vCPU and therefore saving on that license cost. Speaking of storage, I mentioned the instance store that's available in the R5D. EBS storage is our default storage that most people were going to use for their database, for their logs. GP2 and IO1, you may recall, we saw available for Amazon RDS as well. When you're on Amazon EC2, you have a few additional options, and one in particular, the ST1 option, is an HDD option. I don't recommend it for your database or your logs, but where some customers are using this is with the backups. It still has high throughput, and it can provide some cost savings over GP2 or IO1. So we looked at the architecture diagram for RDS. What can we do on Amazon EC2? Well, of course, as I said, you're administering it yourself, so the options are really up to you. But one common method we see is right here with multi-AZ always-on availability group. You'll notice this looks a lot like what we saw with RDS. Two big exceptions. One is that this actually is 2 instances of EC2. The second is you're managing this yourself. So again, those features, the automatic configuration of the high availability, the automatic host replacement, that there are ways you could engineer things yourself, but it's not a managed service. We're not automatically doing those things for you. But then you also have the flexibility to do other things if you would like. For instance, what if you want to take this multi-region? On the left side, you see basically what you saw on the previous slide. And now I've extended this. Notice I'm doing a synchronous commit within the region. Because of that low latency I talked about between availability zones, we can do that. We can do a synchronous commit and have that automatic failover, even though we're going to a new availability zone. But when we go to a second region, now you're going to want to do an asynchronous commit, and then you would be, of course, in a manual failover situation should the need arise. What about distributed availability groups? You may have heard of these, a newer feature, but this allows you to join 2 availability groups together. In this particular case, I have one availability group in one region, another in another region. Both within the AG, they're both doing synchronous commits, but then again, because I'm crossing regions, I have an asynchronous commit using our VPC peering that then bridges the 2 regions and brings the 2 availability groups together. We're going to see this again later when we talk about migrations as a useful feature there as well. Another option, and this is particularly popular with people using SQL Server Standard Edition, is the failover cluster. So SQL Server Standard does not support full availability groups. It does support basic availability groups, but those are only for one database. So sure, you could create a lot of them, but it gets cumbersome after a while. A failover cluster can be done with 2 nodes, even with standard edition, and this allows you to have high availability of the entire instance. Now, when you're doing this on premises, you're typically doing this with shared storage, probably using a SAN. On AWS, we do this a little bit differently. We do this in a way where you're actually not sharing anything, similar to the way availability groups are a share nothing. Here we're not sharing because we're replicating the storage to the other availability zone. So you have 2 EC2 instances in 2 zones, as well as replicated storage in the 2 zones. And this can be done with third-party software such as Sios Datakeeper, as well as with Windows 2016. There are ways to configure this using Storage Spaces Direct. So we talked about why you want to run SQL Server on AWS. And we talked about a couple places where you can run SQL Server on either RDS or Amazon RDS or Amazon EC2. But now let's talk about how do you get there? How do we do that migration? How do we move our data into AWS? Well, anytime you're talking about migrating SQL Server, the simplest way to do it is just a very simple backup and restore. Do a full backup, stop what you were doing, do a full restore, pick it up where you left off in the new location. The good news is we do support native backup and restore. Of course, we do on EC2 where you're managing it yourself, but we also support that on Amazon RDS. Remember I talked before about distributed availability groups. I said we'd come back to that with migrations. Well, here it is. What we're doing here is I have a synchronous commit automatic failover set up in my on-premises availability group. What I'm doing now is I build a second availability group on AWS, and then I bridge the two over our AWS Direct Connect. I bridge the two in a distributed availability group. Once I've done that, now I can take those steps to perform a planned manual failover from the on-premises AG over to the new one on AWS. Well, what do you do if neither of those scenarios works for you? Well, we have the AWS Database Migration Service along with the AWS Schema Conversion Tool. The Database Migration Service allows you to migrate databases, as the name implies, obviously. The Schema Conversion Tool works with that to help you not only migrate your database, like migrating SQL Server over to SQL Server on RDS or EC2, but you can actually transform that database if you want to a completely different database engine. Like you could convert from SQL Server to an open source engine. For instance, MySQL or Postgres, MariaDB running on RDS. Or you could convert to something like Amazon Aurora or Amazon Redshift. But one of the really great things about this is DMS is not just limited to migrations. You can also use DMS to continuously replicate the data. Maybe you want to move over to AWS, but you want to test some things out first before you're sure you're ready to go. Maybe you have a production environment in one location and a test dev environment in the other location. The possibilities are endless, but there are a lot of great ways you can use DMS and SC2 to achieve any one of these goals. One other scenario I want to mention, what if you're currently running on VMware cloud, or sorry, VMware on premises? You can do a migration to VMware cloud on AWS. And in fact, one of the great features of this is it supports a live migration from on-premises to AWS using this. All right, so now we've covered migration. Once you're on AWS, perhaps you want to upgrade your version of SQL Server. So how can we go about doing that? If you didn't do it during the migration, maybe you're using DMS and did it during the migration, that's one way. But if you didn't, once you're on RDS, it really is quite simple, just a few clicks. And we'll go through it right here. So first, you want to identify, obviously, which instance you want to actually do the migration on. You choose that instance, click the Instance Actions drop-down, and choose Modify. Next, choose the version you'd like to migrate to or upgrade to. Then select either immediate or delayed upgrade, and then click Modify, and you're done. EC2 upgrades can be done much like you would do on premises. You can either upgrade in place or side by side. Keep in mind that Microsoft does not support an in-place upgrade to version 2017 for versions of SQL Server prior to 2008. Some of you still might have questions, and if you do, we have several programs available that can help. Some of these involve partners, and if you're interested in working with a partner, I recommend contacting one of our Microsoft competency partners. You can also find additional information on our website, and both the webinar recording as well as the slides will be shared after the event. With that, I thank you for joining us today, and I'll turn it back over to our moderator to open the Q&A.